Hello everybody. This is an interactive video that I have created for you to help review for your exam. Now the way this is going to work is I'm going to show you several different questions and then you are going to answer them. If you get it right, then you move to the next question. If you get it wrong, it's going to bump you into part of this video where I will explain a little bit more to help you with the question. So, as you go through each question, if you get it right, you'll move to the next one. If you get it wrong, you'll see a part of the video and then it will return you to the question to try again. So let's go ahead and start with the first question. I'm afraid you got that one wrong. When you look at the idea of median, the median is a statistic. So right away we know it can't be a parameter. And the issue is, what kind of statistic are we talking about? Inferential or descriptive? Inferential means we're using this to understand something about the population. Is that what we're doing in this particular case? Try again. All right, for this one, you need to understand that how we're using this particular piece of information. Number one, is it a number that represents the entire population? Well, no, it's not. So it can't be a parameter. Therefore, it's got to be some sort of a statistic. How are we using the statistic? Are we using the statistic in order to just describe, or are we trying to infer what's going on in our sample to what is going on in the entire population? We have continuous data and categorical data. Continuous versus categorical. Now, if you remember, there's only one kind of data when you look at nominal, ordinal, interval, and ratio. Only one of those counts as categorical data. Only one of those, because you put things into categories and the number means a category. Frequency means how many times does that number show up? That's all it means. So we're not looking at, oh, look at participant number 3. We're not looking at, oh, which one of these has 3 representations. We're looking at how many times does 3 show up in this particular data set. When you look at skew, skew has to do with the shape of the distribution. Well, if it's skewed, then that means it's being pushed to one side or the other. That means that there is some data that is pulling a measure of central tendency. Specifically, in a positively skewed distribution, that means we have a lot of low scores and a few high scores. What would the high scores do? The high scores don't pull the median, they pull a different statistic. And now we're not saying we're going to add extra modes here either. They're pulling up something else. For this question, just look at the word. Bi means two. So bimodal would mean two. The normal curve has very specific characteristics. And the most important one is that it's the same on both sides of 0 z-score. 0 z-score is the mean, right? So above the mean and below the mean, it's exactly the same. So which one of those would represent something that means that it's exactly the same on both sides? All right, for this question, the first thing you have to do is calculate the mean, because a deviation is one person's score away from the mean. It's how much that score is away from the mean. All right, now I'm not looking at standard deviation here. I'm looking at what is that person's score minus the mean, x minus x bar. So in this particular case, participant 1, their score is 2. You got to figure out what the mean is, and then take 2 minus the mean. That'll give you the correct answer. This is one we practiced in class. If you take all of the deviations, each of the deviations, and then you add them up, that's the sum of deviations. We've done this several different times. So you can even try it in the previous question. The previous question had a list of different samples. You can add them up and see what they add up, all the deviations add up to. And it always ends up being the same thing. Always the same thing. For this one, you got to remember what is a standard deviation. And you got to figure out which one of the statistics has multiples and which one only has one to describe. So let me help you out a little bit here. When we're talking about measures of central tendency, we're talking about mean, median, and mode. And so we know that, for example, mean and median, there's only one mean for a distribution. There's only one median for a distribution. There can only be one of those. There are then measures of variability, which include things like sum of squares and variance and standard deviation, which is a numerical representation of how much all of the scores vary from the mean. So how many standard deviations, not deviations, standard deviations are we going to have for one sample? All right, for this question, the first thing you got to do, calculate the mean. Then you calculate the deviations. Remember, the deviations is the score minus the mean. So for example, for participant number 1, their score is 2. The mean is also 2, so their deviation is 0. 2 minus 2 equals 0. You do that for each one of them. Then you square each one of those deviations. All right, so for example, participant number 1, their deviation was 0, so you square the deviation. So 0 squared is 0. And you add up all of those squared deviations to find the sum of squares. So you got to get the deviation first, then you square each of the deviations, then you add it up. That's the sum of squares. This is a probability question, and specifically, we're looking for something that's going to help us with the addition rule. All this is asking for you to do is remember, addition has to do with or, multiplication has to do with and. So all you're just looking for one of the options that has, in this particular case, or instead of and. That's it. All right, for this one, there's actually kind of two ways you can do it. We know, and I'm looking at it right now, we know that the mean for the population is 2. So the mean is 2. The variance is 4. And the z-score that we have is 2. So there's two ways you can do it. One is you can use the formula that we have, which is z-score times standard deviation plus the mean. If you're going to do that, you say, well, wait a minute, I don't have the standard deviation. Well, you have the variance, and you know that standard deviation is the square root of variance. So what is the square root of 4? Is 2. So our z-score is 2, the standard deviation is 2, and the mean is 2. So it would be z-score times standard deviation plus the mean. 2 times 2 plus 2. 2 times 2 is 4, plus 2 is 6. The other way you can think about it is just think about what is a z-score. A z-score is the number of standard deviations our score is away from the mean. In this particular case, we know that we are 2 standard deviations above the mean because we have a z-score of 2. The mean is 2. Well, the standard deviation, what is that? Oh, it's the square root of the variance. It's 2. So how many 2's are 2 away from 2 is what it's saying. So 2 plus 2 is 4. Plus another 2 is 6. There you go. In a normal distribution, the normal distribution is symmetrical. That means half the scores are below, half the scores are above. Symmetrical. All symmetrical distributions are that way. And the normal distribution is a unique kind of symmetrical distribution. This one is just asking you to remember how to use the uppercase sigma in order to do the calculation. So you start with the participant that's on the bottom of the sigma, and you go to the participant that's on the top. So you're going to start with participant number 2, and then you add up everything starting with participant 2 all the way to participant number 4. So participant number 2 has a score of 4. Participant number 3 has a score of 6. Participant 4 has a score of 1. You're going to add those up. 4 plus 6 plus 1. Starting with participant number 2, going to participant number 4, add them up. All right, this is the first of several different questions where we're going to ask you to go through the steps to get a z-score. So a mean is just add them up and divide by n. So add up all the raw scores and divide by n. N is the number of participants. Now we're going to calculate the sum of squares. Sum of squares, remember, is the sum of each of the deviations squared. So don't go in and square the raw scores. Find the deviation first, square the deviations. Now on the exam, I might give you the raw scores or the deviations. Remember that the sum of squares is the squared deviations from the mean. After you get the sum of squares, then you can calculate the variance. Now remember that for a sample, variance is a little bit different than it is for a population. What you do is you take the sum of squares and you divide it by either n or n minus 1. N if it's the population, n minus 1 if it's the sample. So in this particular case, we know we have a sample, so you are trying to, you're going to get the sum of squares divided by n minus 1. N is the number of people. The number of people here is 6, so it is the sum of squares divided by 5, because 5 is n minus 1. After you calculate the variance, then it's pretty easy to figure out the standard deviation. Just take the square root of the variance. That's all we're doing. Square root of variance is the standard deviation. For z-scores, we have as many z-scores as we have participants. So that's why in this particular question we're asking to look for the z-score of participant number 6. The z-score is x minus x bar. So in this particular case, you look at what the raw score is for participant number 6. That's going to be x. Participant number 6 has a raw score of 5. So that's x. X equals 5 minus x bar. X bar is the mean that we've already calculated. That is 4. So 5 minus 4, and then you divide it by the standard deviation. The standard deviation. X minus x bar divided by the standard deviation. We're saying how many standard deviations is this particular score away from the mean, right? Okay, so this is one of those calculate the raw score things. There's two ways we can do it. Again, I gave you the variance, so you've got to get the standard deviation. So first take the square root of that variance. So the variance is 9, the square root is 3. The z-score we have is 1, so the formula is z-score times standard deviation plus mean. Z-score is 1 times the standard deviation, which is 3. 1 times 3 is 3, plus our mean, which is 12. So the answer would be 15, the raw score of 15. One way you can check this is if we know we have a positive z-score, then we know that the raw score has to be above the mean. In this case, 15 is greater than 12, so we know that our raw score 15 is above the mean of 12, and that would make sense that it would be about 1 standard deviation above the mean. So for this one, what you're trying to do first is you got to calculate the z-score. So we have the information we need for the z-score. We have the mean, the standard deviation, and the raw score. So the raw score is x minus the mean, which is x bar. So 13 minus 12. And then you divide it by the standard deviation, which is 2. Then, for that one, we've got to look it up at the table. So we know that we have a z-score in this particular case of 0.5. So you look up the z-score of 0.5. And in this particular table, we're going to look for what proportion of the distribution is greater than the raw score of 13. So we want the greater than. Okay, now look at this. We know that our particular z-score is above the mean. So we're looking for something that is less than 50%. It's the smaller portion of the sample. So what you need to do is you need to get your z-score, then you look it up on the table, which is table E10 in the back of the book, the z table, and you're looking for the smaller portion that corresponds with a z-score of 0.5. For this particular question, this is a binomial. You either vape or you don't vape. Half vape, half don't. Binomial. You either vape or you don't. That's a binomial. So we're looking for the binomial table. We know that in this particular case, we have a total of 6 people. 6 people that we're looking at. So a total of 6 people means n equals 6. And the question is, what is the probability that 4 or more are going to vape? So when we look at the binomial table, we're looking for n equals 6, and we're looking to add up the probability of 4 plus 5 plus 6. 4 plus 5 plus 6. But which column do we use? Well, we have that in the information right here. The information tells us that 50% of the population vapes. Therefore, the a priori probability will be 0.5. So you're looking for the column that's 0.5. You're looking for n equals 6, and you add up the probability of 4, 5, and 6. Add those together, and you'll get the probability of 4 or more people will vape. All right, everybody. Thanks for watching this. You can go back. You can do it again if you'd like to. Practice the problems. Take a look at what you've got. And as you study, make sure look at your homework. That's exactly the kind of stuff I'm going to ask you. These questions were directly from previous exams. So these are exactly the kind of questions that I want to ask on the exam. Good luck. Keep studying.